So here is our last example for chapter 25, and we're going to look at the twin study. Now, this might sound familiar, so I'm going to just put this little clip in here to give you a snippet of what this would be. But if you guys remember, there's this documentary that came out about a year or two ago that's called Three Identical Strangers, and this situation has indeed happened, although they did not publish the research. So I'm going to read this question, then show you the clip, and then do the work. A researcher studied a random sample of identical twins that were separated at birth and raised in different families. In each case, one twin, let's call it twin H, was adopted by a high-income family, and the other twin, twin L, was adopted by a low-income family. Both twins were given an IQ test as adults. The results are as follows. So the question is there an effect of nurture on IQ? And you can just look at the data and be like, okay, but let's actually do the analysis. So let's quickly watch this clip, and then we'll do the actual work.
That's when things kind of got funky.
Something was just not right.
They separated these boys at birth.
The parents had never been told that there were two other children.
What was the purpose?
Why? How could you not tell us?
They're trying to conceal what they did from the people they did it to.
When you play with humans, you do something very wrong.
Who'd be evil enough to come up with something like this?
There's a lot of powerful people who would like to have this story silenced.
There's still so much that we don't know.
It boggles the mind.
It's a mystery. I'd like to know the truth.
If we compare the two groups, we find group H has a mean IQ of 109.75 with a standard deviation of 9.69. Group L has a mean IQ of 103.6 and a standard deviation of 8.65. Now you might be tempted to compare these two groups using a two-sample t-test, but that would be inappropriate as these are most certainly not independent samples. So this is the reason why we have to run a match pair t-test by finding the paired differences. And so we go to differences, and what we're going to do is say higher minus H-I-G-H-E-R minus lower. And so from here, we see that our 12 pairs have our differences. Now, we are testing the difference in IQ, so our null hypothesis is the mean difference is 0, or there's no difference, with our alternative being that there is a difference, so this is a two-tailed test, with our difference being higher minus lower. So the results are independent from one pair to the next, but the IQs are paired by twins. The samples were randomly selected. The 10% condition is not relevant since we are studying the effect of nature on twins' IQ. A histogram of the differences is sufficiently unimodal, so let's make a histogram. We're going to go menu, doc, and then we go to data and statistics, and we're going to select our difference. And if you want a histogram, we'll go menu, plot type, histogram. And let's make sure that menu, plot properties, histogram properties. We want the bin settings. We'll have equal bin width. Let's say each of those bin widths are 2. We can see that it's roughly unimodal and symmetric, roughly. If we wanted to also look, so we'll hit control doc. Let's do another data statistics. We'll say the differences again, only this time we're going to go menu, plot type, and normal probability plot. And here we're looking for how straight this is, how it relatively fits a line. We also get the mean of the differences and its standard deviation. So let's make a third document and a calculator. And if you guys recall, what we need to do is calculate the standard error, and the standard error would be our standard deviation of our difference, which is 3.96489, divided by the square root of n, which is 12. So once we have our histogram and our normal probability plot, and we see it's sufficiently unimodal and symmetric, the normal model is appropriate with a mean of 0 and a standard deviation of 3.9648. And we will do a matched pair t-test using a alpha level of 0.05. So we have our data entered into our list, and now we are going to do a matched paired t-test. So we're going to hit Menu, Statistics, Tests, and we're doing a t-test. We're going to use our data. Our mean, our null hypothesis is that there's no difference. Our list that we're going to use is our difference. There's a frequency of 1, and we're saying that they're not equal to each other for our alternate hypothesis. We hit OK, and we get our results. So we get a t-value of 5.31, a p-value of 0.0002. Our degrees of freedom is 11, because we have a sample size of 12, with our average and our standard deviation. Now on to the calculation bits. So if we are doing a t-test, remember, t-test, to find the t-score, we take the average minus our delta naught over the standard deviation over the square root of 12. This gives us our standard error to give us a t-score. That's how we get 5.31. Now, just so you guys remember, to find our critical value that we're comparing that to find the critical value for our t statistic, we're going to hit 6, Statistics, Distribution, and we're going to go to Inverse t. Remember, the alpha level is 5.05, so we'll do 0.975 for our area, and our degrees of freedom is 11. And we get a critical value of 2.02. Excuse this error, this should say critical value for 11. So what we're trying to figure out is, what's the probability that our average is greater than or equal to 6.08? Or what's the probability that our t-score is greater than or equal to 5.31 in comparison to our critical value? And since we see that we have a p-value that is below, p is less than our alpha, in this case, we have to reject our null hypothesis. There is sufficient evidence to conclude that being raised in a high-income environment increases adult measured IQ. And since we reject the null hypothesis, we will want to find a 90% confidence t-interval for the actual mean difference in IQ. Likewise, we've met the conditions for a 90% confidence interval, and we're going to use a normal model with our average and our standard error, which comes from, again, our standard deviation of our mean divided by the square root of n. That gives us our normal model that we are using. We're using the same value for our critical value. So our confidence interval is our mean difference plus or minus our critical value with 11 degrees of freedom times our standard error. So that gives us 6.083 plus or minus 2.51. Now, on the calculator side, because our alpha level is 0.05, we want to run a 95% confidence interval. So we hit Menu, Statistics, Confidence Interval, t-interval from our data, from our differences, list of 1.95. Our lower level is 3.56, our upper level is 8.6, our average and our margin of error all match. And so we can be 95% confident a high-income environment will increase IQ between 3.6 and 8.6 points overall. So I hope this walkthrough helped, and I will see you guys for our review for Unit 6.